Hi, I am Amit Dharnia, Assistant Professor in Department of Mechanical Engineering of Arya College of Engineering and IT, Kukas, Jaipur. Today our topic is engine emissions. Today we'll learn about the different type of emissions emitted from the engines in SI engines and in CI engines. So let we start. Engine emissions. The SI engines vehicles without emission control have three sorts of emissions: exhaust emissions, crankcase emissions, and evaporative emissions. Exhaust emissions, although of 100% of nitrogen oxides, carbon monoxides, and 60% of HC emissions are emitted through the engine exhaust or vehicle tailpipe, where in crankcase emissions about only 20% of HCI are emitted, and in evaporative emissions, fuel evaporations from tank, fuel system carburetors constitute another 20% of total HC emissions. And in CI engines, the CI engines only release all the harmful emissions into atmosphere through its exhaust gases. So here we seen that the SI engines, depending upon the engine operating conditions without catalytic control, engine out emissions range are CO emissions 0.2 to 5% by volume, HC 300 to 6000 particulate per million, and NOx 50 to 2000 ppm. The CO emissions are higher under engine idling or full load operations when engine is operating on fuel rich mixtures. HC emissions are higher under idling, during engine warm up and light load operations, acceleration and deaccelerations. NOx are maximum under full engine load conditions, and in CI engines the CO is 0.03 to 0.1% only, where HC are 20 to 5000 particulate per million, NOx 100 to 2000 ppm, and particulate matters. One additive pollutants are particulate matters. These are 0.02 to 0.2 gram per meter cube in CI engine conditions. Here we seen that the basic source of emissions formation in the SI engines, where we can see that NOx and CO are formed in the burned gases in the cylinder. Unburned HC emissions originate when fuel escapes combustions due to several processes such as flame quenching in narrow passage present in the combustion chamber and incomplete oxidations of fuel that is trapped or absorbed on oil film or deposits. NOx is formed by oxidation of molecular nitrogens during combustion at high temperature, which react to form NO. Some nitrogen dioxide is also formed, and NO and NO2 together are called NOx emissions. CO results from incomplete oxidations of fuel carbon when insufficient oxygen is available to completely oxidize the fuel, and HC originates from the fuel escaping combustion, primarily due to flame quenching in crevices and on cold combustion chamber walls, fuel vapor absorption in the oil layer on the cylinder and in combustion chamber deposits, and presence of liquid fuel in the cylinder during cold starting conditions. Here is a variations in CO, HC and NOx emissions for SI engines. There is a graph plot which describes us the different emission contributions, their concentration according to their volume. It the fuel air equivalence ratio. As we said, at low fuel equivalence ratio, all the emissions are about to its low level, but when we achieve the equivalence ratio to 1, then we see that, or at the stoichiometric ratio, the NOx emissions are rising, the HC emissions are rising, and the CO emissions also rising. But at a narrow window, at equivalence ratio 1.0 to 1.2, the most of the emissions are in the equilibrium state. Emission formation in CI engine. Here is a schematic representation of diesel spray combustion and pollutant formation for a direct injection diesel engine. A fully developed diesel spray may be considered to consist of three distinct regions based on the variation in fuel air equivalence ratio across the cross section of the spray as seen radially outwards from the center line of the spray. A fuel rich core, when fuel air equivalence ratio is richer than the rich flammability limits, and flammable region in which the equivalence ratio lies within the rich and lean flammability regions. A lean flame out regions where equivalence ratio is lower than the flammability limits and extend up to the spray boundary. There is also an too lean burn where HC emission formations. The most of the NOx formations is near the schematic combustion, and where the mixture is too rich, or which is known as the core of the flame, the shoot is formed there. And HC emissions also form from the fuel vapors from the nozzle holes. Pollutant formation is strongly dependent on the fuel air ratio distribution in the spray. NO is formed in high temperature burnt gases. In the flammable region, maximum burnt gases temperature results close to symmetric air fuel ratio, and these contributes maximum to NO formations. CO is formed in the fuel rich mixtures in the flammable regions. Shoot forms in fuel rich spray core where the fuel vapors is heated by the hot burnt gases. The unburnt HC or oxygen generated hydrocarbons like aldehyde organoids in the region where due to excessive dilution with air the mixture is too lean at the spray boundaries. In excessive lean mixture combustion process either fails to begin or does not reach completions toward the end of combustions. Fuel in the nozzle sac or orifice get vaporized, enters the combustion chamber and contributes to HC emissions. So here we learn about the different formation of emissions pollutants in the spray core or in the spray of a nozzle of diesel engine, where all the pollutants formations depend upon the schematic air fuel ratio. When the mixture is too lean, then HC formation. When mixture is too rich, then the shoot and NOx emissions are formed. So these are the basic formations of the emissions in the CI and SI engines. Thanks.